Hi, everybody. This is Mr. Folly, and welcome to Podcast 2.1. We're going to talk a little bit about mass, like we talked about in class today, volume, conservation of mass, volumes of containers, densities of slopes, and density calculation. So grab a calculator and let's hop to it. The amount of matter in a substance is called mass. Mass is measured on a balance in grams or kilograms, and we could do some other metric units with it, but we're only going to use grams or kilograms, okay? So if you look, the amount of mass is the amount of stuff, amount of matter inside of it. So on that, see how this, if you added up the total amount of stuff within it, then you can figure that out. So styrofoam is very light, so it doesn't have as much matter packed inside of it. This thing, see how these are all supposed to be little atoms and it's packed very tight, so that would have a lot of mass for its size. Volume is the amount of space something takes up. We measure it in centimeters cubed, meters cubed, or milliliters or liters. Okay, the other thing that we do, we almost rarely use this one, so I'm going to put a little frowny face by that one. But these are the ones we're going to use the most. What you use to measure it is called a graduated cylinder. Sorry, I forgot to put that on there. Graduated cylinder. And that's one of those things that, welcome to my art class. Whoa. And then you have the little mark that goes up here, and you get your eye next to it. And you measure the bottom of the meniscus and all that stuff. I guess I should have put my thing on here. Anyway, hopefully you know what a graduated cylinder is. So let's draw some pictures of some things. So if I have a small volume and a big mass, that means it's going to have a bunch of stuff packed in it. Okay, so if I have a box of something, that would be small volume, big mass. Big volume, big mass. Oh man, I shouldn't have done this one because this is going to take me a while to fill up. All right. So notice the big volume means my box is going to be bigger. And it's a big mass, meaning that there's not much empty space in it. I guess I could have made these circles instead of colored in circles, but you live and you learn, right? So we'll pretend this is filled and filled all the way up. And I'm going to even emphasize my filledness even more. So that would have a big mass, okay? Big mass means you got a lot of stuff in it, right? Small volume, small mass. So small volume, I made this big. Small mass would be something like this. So this would be like an empty box, right? An empty box would be an empty small box. Big volume. Wait, didn't I just do big volume, big mass? Big volume, big mass. So I'll do big volume. Oops. Small mass. Big old box. But a little tiny mass. So this might be like a giant thing of styrofoam. So it's huge. It takes up a lot of space, but it doesn't weigh very much. Okay. And not that it specifically has to have 3, but you get the idea. So small mass. So lots of dots equals lots of mass. Okay. Okay. These things, this would weigh to have just a bit more mass than that. Mass is never created nor destroyed. It just changes form. Okay. Freddy weighs 150. No, we'll call that pounds. He eats 2 pounds of Bosco sticks. What does he weigh? So if mass is never created nor destroyed, that means he just weighs 150 plus 2, and now he's 152. Make sense? All right. 70 grams of iron is left out overnight. It now weighs 73 grams and is rusty. Where did that weight come from? Now, it has to come from somewhere. Okay? So it became rusty. So what happened is I had iron, and then what's in the air around us is oxygen, right? We breathe the oxygen. So I start with 70 grams of this, and what I end up with is FeO. Okay? So what happens here is I end up with 73 grams, but I had to add some oxygen, so I must have had 3 grams of oxygen. So we need to know that air, or gases, have mass. All right, volumes and containers. In the movie Seven, one of my favorite movies of all time, Gwyneth Paltrow's head is delivered in a box like the one below. It's a true story. If I fill the box with water, will that volume equal the volume of the inside of the box or the outside of the box? So, for example, on this part, if this outside to outside was 10 and this inside was 8, right? And this outside to outside part was, let's say, 5, and this inside to inside part was 3. Right? So it's just going to be the inside part. I know this, I hope this seems kind of obvious to you, where it's not the whole size of the container, it's the space on the inside. Okay. So if I fill the box with water, will that volume equal the volume of the inside of the box or the outside of the box? It is the inside. Why not the outside? Not outside, because that is styrofoam. Ah, ah, ah. What's that called? Foam. Mass and volume are related graphically. Okay. So what I'm going to do here is mark off a happy little graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So what I did here is 2, 4, 6. Oh, I was going to do 1, wasn't I? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this goes up to 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so the bottom part is mass. That should be labeled on the bottom. Sorry, I didn't give myself enough room. And this is volume. My volume is in milliliters. My mass is in grams. Okay, so what I'm going to do is I'm going to take 2.77. So if my mass is 2.77, my volume is 8.3. So 2.77, 8.3, doink. 3.77, 11.3. Okay, so there's 11. Doink. 4.77, 14.3. 14.3. Doink. And notice how I'm not crazy with being super exact, but they're really close on these, okay? 5.77, 5.77, 17.3. Now, I've graphed these points, but I haven't talked about them very much, okay? And then 6.77 goes up to 20.3. And then this would be 22. So mass and volume are related graphically. So if I have this, so if I said this was iron, and I have 3 different masses of iron, and the volume changes. Well, no kidding. If I have a bigger mass of iron, it's going to take more volume. But what you should notice is that these are, I'm going to circle these points so you can see them a little better. These points make a straight line, right? I could have aimed a little better, but they make a straight line, okay? And if they're related graphically, remember the formula for line is y equals mx plus b. So on this, what we have is this m is the slope, right? And the slope will always be the same, right? So if I took the mass and divided it by the volume, mass divided by volume, I would get a calculator. I told you guys to get one. I hope you did too. So I do 2.77 divided by 8.3, and I'd get 0.333, or yeah, 0.334. If I did the same thing here, 11.3 divided by 3.77, oops, I did that wrong. 3.77 divided by 11.3, I get 0.334. And all of these will be the same. So that ratio of mass to volume is the same. Density is constant because slope is constant. That ratio of mass divided by volume, mass divided by volume, mass divided by volume will always be 0.333. Density can identify a substance. 8-hour's brain has a density of 4.33 grams per milliliter. Is this a graph of their brain? So if the density is 4.33 milliliters, is this a graph of their brain? if the slope is 4.33. But what's the slope here? The slope here is 0.334, right? So the slope is 0.334, so the answer is no. Other way to find slope is take 2 points, right? Any 2 points, and you do change. Remember, delta is triangle, change in y over change in x. So this went from 20.3 to 17.3. So that is a change in 3. So that's 3 divided by change in x, which is 1. Oops, did I do that right? I did that backwards. Rise over run. Oh, I did this backwards, didn't I? That's okay. So it should have been 3 instead of the other way. But I divided them in the other way. So the slope here is 3, not 4. Sorry. I did this to show it was constant, but we always do mass and volume the other way. So, oopsie. But still, the slope is the same. That's what we're looking at. So what is the slope? We've got mass, we've got volume. What is the slope? So this is 5, and this is, let's pick the last point, 35. So we're going to do, change in y over change in x. Change in y, this went from 25 up to 175. Be nice if it stopped doing that. So the change in y is 1. It'd be really nice if it stopped doing that. 175 minus 25, parentheses, over 35 minus 5. And that's going to be 125. Oh, it's not. It's going to be 150 over 30, which is going to be 5. That's the slope in grams per centimeters cubed. Okay. What's the slope of the liquid? Now here I'm going to try and pick something. Hopefully I can find some easier ones to do here. This one right here. I guess we'll start here with 0 and 0, right? So change in y over change in x. So if I go from, get back here. My change in y, let's go all the way up to here. So this is 8. I'll use this point, and I'll use the origin. 8 minus 0, and then we'll use 80 minus 0. See, I start with 0. These are the 2 points I'm using just to make them really big. All right? So 8 divided by 80, hey, I can do that. That's 0.1. That's the slope. So what's the slope, and what's the density? So that would be grams per milliliter. And this one would also be grams per, I guess I did centimeters cubed. So density has a formula of mass over volume. Do you see how it's rise over run? Do you see how it's rise over run? We had mass was the rise, volume was the run. That's the teach in math class. So we need to do this with algebra too. So if density is 13.5 equals 151 over V. This, I think, is the hardest question that we do because we have to make sure we move the things. I'll multiply both sides by V. 13.5 V equals 151. V equals 151 over 13.5. Do you see how literally we just switch this? Cross multiplication is my favorite thing, so use it all the time in chemistry, algebra, all algebra. Get the idea. V equals 11.2. Since my density gave it to me in milliliters, my volume's in milliliters. Now I'm going to solve for density. Density is mass over volume. Get back here. Density equals 325. That's my mass over my volume. 375. 325 divided 375 is 0.867 grams per milliliter. That is it. Woohoo! Density is the slope of mass and volume. So we've got to be able to use slopes. Density is mass over volume. Mass is the amount of matter. Volume is the amount of space. And podcasts are the amount of fun. It should be illegal to have, but it's not illegal. We can keep doing it. And I will